Other parts were rather interesting, like chemical bonding and then periodic table. Yeah.
Mhm. Okay, so we are starting with your one of the likest subject topic, that is periodic table. So you'll be happy, I guess, today. Okay, so Trisha, what about you?
Yes, so I'm Trisha, and so I used to hate chemistry in grade 8, but then in grade 9, chemistry became a little bit more easy. So now I love chemistry.
Okay.
And yeah, I think chemistry is one of the subjects in which I scored the most, and that's one more reason to like it.
Okay, yeah. So, because I used to score the most in chemistry, that is the reason I end up doing my master's in biochemistry, because I didn't want to leave chemistry. So,
Yeah.
I guess this is the thing, we feel that in the subject we are scoring more is the, what you say, favorite subject that we have, is it? All of us?
I mean, like that also affects the liking of the subject.
Okay. Yeah, correct. Fine, then we'll start doing with the new topic, like today's topic, that is periodic table. Yeah, other than that, I just observed that all of us are wearing specs. So it is like A batch is specs batch.
Yeah, maybe studious we would say. I would quote it as studious.
Okay, yeah, okay. Not bad to see that. Okay, fine. I'll just share my screen. So what I have done is I have made the small PPT. Okay, in that we will just brush up that the, because we had in ninth standard also periodic table, right? If I'm not wrong. So we'll just brush up the things that we have already studied, and then I'll add the new things that are there in 10th grade, so that you can correlate from that. Okay, fine. Just a moment. Yeah, you guys can see my screen.
Yes, ma'am.
Okay. So because we have just finished our ninth grade, so we all know what is periodic table and what is the need for periodic table. So I'll just explain it now once. So periodic table, we know it is the arrangement of elements in a specific manner, and which manner I'm talking about is this. Which kind of periodic table is this? Is it the
The
Bernier's period? Modern
modern
periodic table.
periodic table.
Yes. So there, what happens in science community is if someone discovers something, there will be someone who either will try to prove you wrong, or he'll come with something which is more, what you'll say, interesting or more useful or knowledgeable than the other person has just discovered. So that is the reason there were a lot of scientists who worked on periodic table. It started with which scientist?
Dauvergne.
Okay. And who was the last one, which we are following till now?
Muesli. I mean, I don't know how to pronounce it.
Yes, correct. So what happened was first the Berniers came, and see, the thing is the first person who would have discovered, he used the most of the creativity, right? If I have made a recipe of something without knowing, like, okay, now we know there are a lot of things, pizza, then you made the bread pizza and this pizza, that pizza, but the person who would have made the first pizza would call the authentic recipe of the pizza, right? So here the same thing with our periodic table. The person who understood that yes, there is a need to arrange the elements, should be regarded the first one, right? Should be given most of the, what you say, what that he should be given the most of the credits, that yes, this person has got. But what happens in science community is, you can say this as pros and cons of science community, being a researcher or being a scientist. What happens is, until or unless you are being observed, when you are your credits or your work is getting published, like Robert Nears was getting credit till the time his periodic table was there. Once it came out of the market, nobody knows. So it was like that. So we know de Bernier came, what he gave the law of triads. What does that mean? What is the law of triads?
When elements are grouped of three and the middle element is the average of the other two neighboring elements.
Okay. So yeah, Shans, can you just explain me the example of the Debornius triad?
I'm not sure actually what would be an example of Dobbernius triad.
Lithium, sodium, and potassium. Just now we have finished to ninth.
Yeah.
Lithium, potassium, lithium, sodium, and potassium. Am I correct, Sanjana?
But which like which person
Okay.
told about the eighth one though?
Eighth one.
Like the eighth element was the repetition of.
Newlands. Newlands.
Oh, that was Newland. Never mind. Sorry.
So okay. So I was talking about this law, which is Dobernier's triad. Dobernier triads are the group of elements with identical properties that were discovered by this particular person, which had surname as Dobernier. He was a German chemist. He also observed that the group of three elements, so-called triads, could be formed, where all the elements shared the same physical and chemical property. Okay, so for this itself, I was giving you the example. So I was talking about this particular triad, which is lithium and potassium. Okay, which has the average identical atomic mass of that of sodium. So middle one. This is what we are talking. Do you want me to explain that on board?
Ma'am, can we take any three elements in
Not
a group?
any three. Yeah, that was because that time, no, there were not a lot of elements that was
Yeah.
discovered.
Yeah.
So whatever were there, see, that is what we sort things. Like you sort your Almira based on the clothes that is already there in your wardrobe, right? You will
Yeah.
like occasionally wearing clothes will put on one side, all the jeans on one side. Like that way itself you will be doing, right? So whatever he had that time, he tried to observe, like he tried to sort them out in a certain way, specific way. But then what happened, we got new what you'll say elements discovered. So he found it very difficult to put them in his periodic table. So that's why someone else came in picture. New person, new scientist has come who was already studying the Bernius triad. He was like, okay, let me try my luck. He tried, he worked very hard, he tried to sort, then again he sorted out in a certain manner, then somebody else came. Now which somebody I'm talking about is after the Bernier, who came, Sanjay?
Newland. Oh, sorry.
Newlands. Yeah, Newlands, he gave a law of octave. What he said, the way we have in our piano or music, we have sa, re, ga, ma or do, ra, le, mi. Uh, the same way, the sa will repeat after the eighth. The same way in our periodic table, the properties are repeating. And he was also not wrong till a certain extent because it was happening. So let me just show you. Yeah. So this is what sa, re, ga, ma, pa, dha, ni. Again, sa will come, right? The same properties are here repeating, which is hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, and then fluorine, right? Why fluorine? Hydrogen also needs one at one electron to fulfill its duplet, and even fluorine need one. But later on, now we know what is the difference between hydrogen and what is the difference between fluorine, because we have the knowledge that fluorine is a halogen, whereas what is hydrogen? In which group does hydrogen come?
Alkali metal, right?
Alkali metal.
Yes. So it will prefer to either do a covalent bonding or it will form H plus, right? It will donate its one electron. Any doubt? Yeah.
Ma'am, but it can be placed in the group of halogens or in alkali metals, right?
Yes, yes. That is the reason you have studied about deuterium, tritium, and all these things, right?
Yeah. Yeah.
Yeah. So what happens is the most favorable when we try to, and not we tried, in nature, if you see, what has happened is hydrogen favors more. Like if you say in case of water, it is for forming which kind of bond? It is a polar bond or a non-polar?
1 second. I mean, it's
Polar.
covalent, but
Polar bond.
Polar. There is a charge separation. I'll teach you that also. No worries. That will also be in one chapter. You have. I was asking you this because we have studied a chapter called water in our ninth standard, right? Okay. Okay. So what happens is, yeah. So Newland, he kept it in like that. Okay, I guess there is a new person who has joined. Hi, Sneha.
Hi, can you hear me?
Yeah, I can hear you. Can
Okay.
you just turn on your camera?
Yeah, once.
Okay, students, so we are all on the same path, right? Hi, Sneha. Myself, Preeti, and I am your chemistry teacher.
Okay.
And today we have started with our periodic table, which was part of your ninth standard curriculum as well as 10th standard. Okay. So we had just started with that and we were just brushing up the things that you have already done. Okay, so we were talking about different scientists who had given periodic table and what was the need of periodic table and thing. So we were currently doing, we have finished law of triads, which was given by de Berniers, okay, which who was a German chemist. And now we were talking about Newland, who had given a law of octave, according to which the element will repeat its property after the eighth element as it happens in the music notes. Okay, so now I guess we are all on the same page. So now we will start with what? Next, who came after Newlands?
Mendeleev.
Mendeleev.
Mendeleev. Okay, so what did he do? Shreyans will tell me now.
Ma'am, so Mendeleev arranged all the elements in their increasing atomic weights.
Yes, very good. So that's all.
And so, as the weights were, uh,
Shans, just hold on. Sneha, can you please turn on the camera? Guys,
Yeah, I was just getting my chemistry.
okay, no problem. So I just wanted to make a small announcement that I don't prefer students turning off the camera because I myself don't turn it off. So I just want to see the face, not for because I'm doubtful if you are listening to me, because I like the session to be interactive. Like if I will see you, then only I'll be having this that I want to teach, or else I'll be like my laptop only. No, what is that? So that is the reason. And other than that, yes, that is one of the thing. If you will be seeing me, I'll be seeing you. That will be a more of interaction, and then we can study more. Okay. So yes, we were talking about Mendeleev's. So yeah, this was the Mendeleev's periodic table. This particular thing, and this is how he used to look. He's Mendeleev. Okay. So what he did, uh, he was a Russian chemist and was most important contributor, because if we see our modern periodic table looks somewhat similar to that of Mendeleev's periodic table, right? It is almost the same way, but yes, what we have done is we have arranged it on atomic number instead of atomic weight in modern periodic table, not we, Musley. So what happens here is he's a Russian chemist. He was a Russian chemist and he was the most important contributor to early development of periodic table. Many periodic tables were made, but most important one was the Mendeleev's periodic table. So once after the rejection of Newland's octave law, Mendeleev periodic table came into the picture. In Mendeleev's periodic table, elements were arranged on the basis of their fundamental property of atomic mass and chemical property. During Mendeleev's work, there were only 63 elements that were known, and after studying the properties of every element, Mendeleev found that the property of element were related to their atomic mass in a periodic way. He arranged the elements such that with similar property falls in the same column. Okay. So did you understand what is the similarities? Okay, so if we have seen so far, see, triads, there was 3, right? Then came Newlands, which had 8. So if you will see, like what you say with the sight of a detective, you can see that they also copied a bit from the previous one. If you see Mosley, what he has done, he has just arranged the instead of atomic weight, he has taken atomic number as the periodic property, right? But till now we are following that periodic table, and maybe one among you can what will say make a new periodic table, and then maybe it will be Trisha. We'll be studying a new periodic table given by Trisha, or maybe Sneha, or maybe Sanjana, or maybe Shreyan. Okay, or maybe Swati also. Sorry, Swati, I couldn't see you. Swati, can hi Swati, I'm Preeti. I guess today I'll be doing this itself. So my name is Preeti, and I'm your chemistry teacher. Okay, so we were talking about your chapter that you have already studied in ninth standard, which is a part of 10th standard curriculum as well, which is periodic table. Okay, so you would have understood that we were talking about all the things that were done by scientists. And yes, you are late, which is not acceptable. You are not supposed to do that from the next class. It is 1 hour session. If you will come half an hour late, no point. Okay, no problem. So fine. So are you guys excited to see what is there in 10th standard syllabus, what we have not studied in ninth? You want to see that? It will not be difficult, but yes, it will be interesting. Okay. So if you are not till the time, till now we were discussing the things that you have already done. So now we'll be discussing new thing. And yes, I want you guys to be very open. If you're not understanding, there is an option of raise hand. Okay. You can raise your hand whenever you feel I am not understanding. Let's not keep any doubt for the next class. Okay, whatever doubt we are getting, let's clear it in like one class, and we should not like feel that okay, what she will think. Let me think whatever I want, but you should understand. Okay, fine. So now I'll be sharing my screen with OneNote. Okay, just a moment, students. Okay. So are you guys aware of ionization potential and all these things? Any idea?
Yes, ma'am.
Yes, ma'am.
Okay. What is ionization potential?
Is it the amount of, not sure, I forgot. Is it the amount of energy to uh, released by an atom? To
Okay. You are somewhere near. I know you would have studied it somewhere. Okay, fine, no problem. I
Isn't it
just
the
want
amount of energy required to remove an electron from a
From the valence
particular
shell.
from the yeah, from the
Yeah.
valence shell?
yes. So
When it
this,
is
you
in
know what, there is a phenomenon that most of microbes follow, that is known as cooperativity or symbiosis. I guess this is happening here. Okay. I didn't want to say that you are microbes, but I just wanted to say that this is happening. Okay. So okay, I'll just paste it over here, I guess, somewhere. It is not coming. Why? Fine, I'll paste it over here. Here now. Later, I'll change it. Okay. So fine. So here we till now whatever we have studied, everything was there in our ninth standard. Now I'll be just starting with the modern periodic table itself. So in modern periodic table, mostly the things that have been considered is the elements have the periodic property which is based on their atomic number. right? So, what are the periodic properties here? All the periodic properties are based on few things. That is atomic radius. What is atomic radius? All the
It is the
The distance
properties.
distance
between
from
the
the
center
center
of
of the
the
nucleus to the
Mhm.
valence electrons.
Yes. So, why we are studying this is all the properties of element are based on all these things. Okay, ionization potential, atomic radius. This will decide where we should keep them. So, as correctly said by Trisha and Shyan, the atomic radius is the distance between nucleus. So, if this is the electron, this is the atom, this is the nucleus. From nucleus to the valence shell, whatever is the distance, that is known as the atomic radius. And then we have ionization potential. What is this? We just said no. It is the amount of energy required to remove an electron from the outermost cell when it is in gaseous state. Okay, that is known as ionization potential. Let's take example of sodium. What is the electronic config? First, electronic number. What will say? Atomic number of sodium is
11.
okay. Configuration.
281.
281.
281.
So what it will do? Will it gain the 7 electron or will it lose this 1 electron?
Lose one
it will
electron.
lose one
So,
electron.
okay. So to remove this 1 electron from the atom, we need some energy. So the amount of energy to remove 1 electron from sodium to make it Na plus is known as ionization potential. Okay, clear? Then we have electron affinity. What is electron affinity?
The amount of
The amount of
energy
energy released to
released
accept
when,
an electron.
yeah,
Shans will always start and then girls will take over and Shans will be like, okay, you guys can complete. Hi, anyways, no. Shans, you can carry on. I will listen to you.
no, I was just saying it's the amount of energy released when an atom accepts one electron in the gaseous state.
Yes. So when an atom accept the electron, so here we can take example of our chlorine. What is the atomic number of chlorine?
7.
17,
So electronic configuration?
287.
2881.
Oh, no, no, no. 2881. Count how much it is.
Yeah,
10.
sorry, my bad. Yeah.
18, 19. Which one it is? Potassium. Okay. 287. So it needs 1 electron. So amount of energy released when sodium gains 1 electron to make Cl minus is known as electron affinity. Now, don't get confused between different terminologies like electron affinity and electron negativity. Okay. We will be seeing the difference also. So here, what is electronegativity?
Tendency of an atom to attract electrons towards itself.
I couldn't hear you, Sneha.
The tendency of an atom to attract electrons to itself.
Itself is known as electron negativity. Is it somewhere similar to electron positivity, electropositivity?
No, because positivity is the tendency to lose electrons.
Yes. Right? Clear, guys? What we are talking here? Electron negativity is the tendency. So can I take the example of chloride ion again, chlorine again, to show that it is electronegative? Is chlorine electronegative? Yes, because it has tendency to gain electron. Can sodium be electronegative? Can sodium gain 7 electron? Sodium is electropositive because it will prefer to leave its 1 electron rather than getting 7 from outside. Okay. So electronegativity, as correctly said by Sneha, is the tendency to gain electron. And what is electronegativity? It is the amount of energy released when there is addition of electron in any atom, in when it is in gaseous state. Okay. Then after that we have non-metallic and metallic character. So do we know that metallic elements are someone which will lose the electrons? Non-metallic will always gain the electrons, right? So see, if you like, I don't want you guys to get confused because their all game is all about electrons. Electrons movement will decide where to place a particular element. So if you are getting confused with where what is happening, just let me know. Okay. So metallic and non-metallic character will also decide their position. So metallic elements will always lose the electrons and non-metallic will keep. Metallic and non-metallic character. Okay. Then after that, there are few different things like melting point, boiling point that we will be seeing later when we are studying. So these are till now, these are the 1, 2, 3, 4, and 5. 5 main properties which will decide where to keep a particular element in the periodic table. So any doubts in any of these terminologies: atomic radius, ionization potential, electron affinity, electron negativity, and metallic and non-metallic character? Any doubts? No? Good to go? So now what I will be doing is we will decide where to put which element based on these properties, and we'll be seeing their trends. We'll be seeing what is happening in across a group, across down a group, across a period. All these things we'll be seeing which character is increasing, which character is decreasing. We'll be seeing all this thing here. So now let me just talk about the term atomic size. Now we know what is atomic size. Now we'll see the trends. So as correctly said by you guys, it is the distance from the nucleus to the valence electron. So now how when it will increase? I'm just giving you example. Just let me know if the size is increasing or decreasing. Okay. So what is happening here? This
It's
is
Ma'am,
the
just one
down.
decreasing.
question.
Mm-hmm.
Is 288 1818 possible? Because
Yeah. Yeah.
because no,
288.
then the valence shell has to have 8 electrons, right?
That is like, yeah, there are, that is not there in your syllabus, but the where what will say valence cell can accommodate 288, 18, 18, 32. 288, 18, 18, and 32 is the possible thing. Okay.
Okay.
But the elements that we are studying till 10th standard is alkali metals, simple things. There you don't have to break your head so much. Don't worry. I'm just giving this for the sake of you to compare. Is the size increasing or not? That's all. So yeah, is the size increasing?
Yeah, it's increasing.
It
Yes,
is
ma'am.
increasing. So now I'll be just taking the example that as the number of shells are increasing, the size, atomic size is increasing. So for example, 281 is sodium. 2881 is what? Potassium. So
Potassium.
is there an increase in size?
Yes,
Atomic radius? Is the size increasing? Yes. Why? Because number of shells are increasing, so size is increasing. But when you move across a period, what happens? The elements will be adding to the same shell. Let's say take example of oxygen and fluorine. So what is the atomic number of oxygen?
6.
8,
8.
8.
Fluorine?
9.
Right? Is the size increasing in this case? Is the atomic size increasing? Is the atomic size increasing? And if you are saying yes, you need to say why. If you're saying no, you need to say why. So just think wisely and then you tell your answer.
That's the same number of shells.
So what happens like that?
So the size doesn't change.
Size doesn't change. But like what if electron is entering? No, what if it gets enlarged, something like that? Nothing happens like that.
The nuclear charge increases, so the atomic size decreases.
Yes. So what happens is when there, as you move down the group, there is the increase in number of shells, which is showing us that there is a increase in atomic size, right? But as you go across a period, what happens? The electrons will get entered to the same cell, right? And in case of group, there is the number of shells which will dominate over nuclear charge. But in case of period, the nuclear charge will dominate and hence the size will decrease. Nuclear charge will try to attract it to itself. Okay. So as the charge is increasing, it will try to hold it more tightly. That is why we are not able to take out 7 electron from fluorine, but like instead we just give it 1 electron. Shaz, are we following the same thing?
Yes, ma'am. I was just going through the textbook.
Okay. So if any point of time you are feeling that it is becoming a bit boring or it will only become boring if we are not understanding. So if we are not understanding or if it is becoming boring, just let me know. Okay. We'll take a 2-minute break, then we'll start again. Just don't lose the concentration. That is what I mean. Okay. So now we understood the trends of atomic size and the reason why it is increasing and decreasing in a group or a period. Okay. So this is what is going to be the question. If in case you are getting in exam, the question will be some elements will be given. Can you arrange them based on their increasing atomic size? Can you tell among these elements which will be having the biggest atomic size or the largest atomic size? Or they can ask what is the trend as you move down the group, what is the trend of atomic size? So these kind of questions will be there. Okay. Okay, let me see if we are missing anything. We have covered this, we have covered this. Okay, so now if you see in a group, alkali metals. Okay, let me just paste the periodic table here. Yeah. So, Shreyansh, can you tell me which element is having the smallest size?
Ma'am, I mean, in the entire
Among
table.
this beryllium, magnesium, calcium, strontium, barium, and iridium.
Oh,
Which is the
beryllium will have the smallest atomic radius.
smallest? And which will be having the largest?
Radium.
Radium. Good. Are you understanding the reason now? Yeah. We are following the same thing. Shall we move to the next property? Okay. So now we'll be seeing the ionization potential. So now we know what is ionization potential. Can Shruti tell me what is it? Shruti, are you there?
I have a doubt in atomic size.
Okay, please tell me what is the doubt.
Ma'am, so why does neon have a bigger atomic size than fluorine?
Neon is, first of all, it is a noble gas. Okay.
Okay.
It has its complete octet. What is the atomic number of neon?
10.
So it is 2, 8,
Yeah.
10. It don't need anything. So in case of this, because it is a noble gas, what happens here is this becomes the exceptions. Okay, so there is already everything is fulfilled, so nuclear charge will not be able to overcome, hence this is the reason it will be having the more.
Like, are there too many electrons? That's
Not
why
too
it
many,
can't.
it is like the octet is fulfilled, that is overcoming, that is becoming superior, it is like
Oh.
self-efficient.
So the
Understanding?
nuclear charge, I think the protons can't attract the electrons, right?
Yeah, that is what nuclear charge will not be able to attract it or hold it for a long time, they'll
Got it, got it.
disperse.
Got it.
Swati, I wanted to ask you, what is ionization potential? Shruti, Swati, are you talking anything? Are you guys able to hear her? No. Shruti, are you talking? Okay. Shruti, you can just fix the problems and then you can come back. And Sneha, can you tell me what is ionization potential?
It's the amount of energy required to remove an electron from the outermost shell.
In the gaseous state, isolated gaseous state. Remember that. Okay. Always use this terminology, gaseous state, if the definition has been asked. So now the factors that affect ionization potential are again atomic size. If the atomic size is big, so the last electron is very loosely bound. This is the main nucleus. This is the last electron. It is very loosely bound. You can easily take one, right? What I can give you example, if there is a box where are a lot of candies, if you take one, it doesn't make a difference, right? Clear, nothing will happen like that. But if there are limited, if you take one also, it will make a difference, right? If there are only two candies, let's say, if you take one from it, it's only one that is remaining. But if there are 100 candies, if you take one out of it, no much difference, right? So again here, atomic size is one of the thing that affect. If atomic size is increasing, it will become easy to pull out the electron, and that is why ionization potential will decrease, because you need less energy, because ionization potential says the amount of energy required, so you will need less energy as you go down the group. So hence what is happening to ionization potential, it is decreasing, right? And what happens, nuclear charge, as nuclear charge increases, the ionization potential increase. Now again we got the reason for that. Nuclear charge is there, it will try to hold the electrons more tightly. Nuclear charge which is applied by the nucleus, it will try to hold it, and because it will be holding it, you need a lot of energy to remove the, what will say, valence electron. So as you move down the group, the distance is increasing. Okay, so the distance, number of shell overcome over nuclear charge, so hence the ionization potential decrease. But as you move across the period, you go like this, what happens, nuclear charge is more. Okay, nuclear charge is increasing. Yeah, Sanjana, please tell me.
I just had a doubt. If the atomic size of neon increased and if ionization potential decreases down a group,
Neon, okay, yeah, tell me, complete yourself.
ma'am, so how does the ionization potential affect noble gases basically?
So you can't remove, first of all, electrons from
Yes,
noble
ma'am.
gases. So we, neon is in period, group is this, period is this.
Yeah.
So these particular things are group, these particular things are periods. So where is neon? Neon is here,
Oh, right,
right?
right, yeah.
So if you go like this, the ionization potential will decrease. But if you go like this, ionization potential will increase because
Okay.
nuclear charge will over.
Okay, got it.
Understood? So yeah, we understood what is the ionization potential and what are the trends and what are the reason for those trends. Shreyansh? We understood?
Yes, ma'am.
Okay. Sneha, you don't need to unmute yourself. Just show me a thumbs up. I will understand you have understood. Okay. Trisha, we are good to go. Yeah, good. Okay, fine. So now we'll be moving to the new property. What is the new property? Is that electron affinity? So now we'll be talking about, okay, I'll just write the trend here. In group, IP will decrease. Across period, IP will increase. So now we'll be seeing the term electron affinity. What is electron affinity? Sanjana?
Ma'am, it's the amount of energy released by an atom to accept an electron
Yes,
in its gaseous state.
released. Okay. When an atom is accepting the electron in gaseous state. Okay. So now this also depends on two things, that is atomic size and the nuclear charge. So what will happen as atomic size is increasing? What will happen? Electron affinity will decrease, because first thing, so now we know as atomic size will increase, they will more probably lose the electron instead of gaining it, right? But what is the reason? Electron affinity is the tendency to attract, right? Electron affinity is the energy released when the atom is accepting the electron, but as the alkali metals, or if you go down in the group, they will most probably try to lose the electron, so it will decrease it. Okay, so more technically, if I want to say something, I can refer your book. So in your book, it is mentioned as electron affinity is the tendency of an atom to accept the electron, as we just said. A small atom takes up electron more readily. For example, fluorine, right, will take atom electron more readily. Then because the nucleus size is small, right, and the as you go down, there are this nucleus sizes becoming big, and that is the reason they will not be able to take up. Are we having any doubt in this electron affinity? No. And when nuclear charge increases, the electron affinity increase. So, but in case as you move down the group, we know nuclear charge increase, but the number of shells will take over. But as you go across the period, as nuclear charge is increasing, the electron affinity will also increase. Okay, so now let's see here what I mean to say. As I move here down the group, the electron affinity will decrease, right? But as you move across the period, the electron affinity will increase. So that is the reason this is more electronegative or than beryllium or magnesium, right? Okay. So now we have a new other. Yeah, Trisha, please ask. Shriyansh also. Okay, please tell me one by one. First, Trisha.
Ma'am, just a clarification for ionization potential and electron affinity, both of them we need to relate everything to the attraction, like the nucleus
Attraction.
attraction.
That is what I said. Everything, every concept here depends on atomic size and nuclear charge. Every particular thing. You talk about ionization potential, you talk about electron affinity, you talk about whatever, like
Okay, okay.
electronegativity, everything is based on atomic size. Okay? Yeah, Shreyans?
Ma'am,
You
I
are
didn't
on.
quite get what exactly the nuclear charge is. I'm slightly
Nuclear
confused.
charge is the force of attraction that is applied by nucleus in order to hold its structure. So this is the nucleus. Nucleus will be having a certain charge on all the revolving electrons to keep it in this particular gaseous atom state.
Okay.
Understood?
Yeah. Okay. Thank you.
Okay, we are good to go. I'll start with the other thing, that is electronegativity, another terminology. Electronegativity. So, electronegativity is the tendency to accept the electron, and it is somewhat similar to that of electron affinity in trends. As you move across the period, electronegativity will increase. As you move down the group, electronegativity will decrease. Right? Because it also depends on atomic size and nuclear charge. As atomic size increases, electronegativity decreases. Right? And nuclear charge, as nuclear charge increases, electronegativity increase. So if you see in a group, nuclear charge is increasing, but number of shells is taking over. So that is the reason the electronegativity will decrease. But as you move across the period, nuclear charge is increasing across the period, and that is the reason that our electronegativity will increase. Are we missing on any point, whatever we have done so far?
Ma'am, for electron affinity,
Hmm.
why does chlorine have a higher electron affinity than
Okay,
fluorine?
that is an exceptional case. Okay, so what happens is when you see in chlorine, what is the atomic number of chlorine?
1 second.
17.
Oh, sorry, yeah, 17.
No problem. So what happened? There are different force of attraction. I will cover that in another portion, that is like down this. So what is there is there are different forces of attraction that we call London forces, van der Waals forces, that dipole attraction. So in case of chlorine, these forces are varying if you compare to that of fluorine. That is the reason it has a larger size. Okay, I'll just come to that in detail when we are studying that particular portion. Okay.
Okay, got it.
Yeah, I just didn't want to confuse. That is why I'm just keeping it very simple. Don't worry, we'll cover everything. Are we good to go so far? We know all the trends, what is happening in which trend, and what is the reason of whatever trend we have studied. Okay. So yeah, now your question will come here after this. So there are different properties, that is metallic property, non-metallic property, and for today's class I'll just keep it simple till metallic and non-metallic. Next class when we will come, then we will discuss all the forces, different forces that exist. So metallic property, we know if a atom is losing electron, it is called as metallic atom. If if an atom is gaining electron, it is called as non-metallic atom. Correct? So can you give me example, Swati, for any metallic atom? You are on mute. Sodium, yes, I could only read your lips, but I couldn't hear you. Okay, no problem. So fine. So sodium is a metallic atom. And Sanjana, can you give me example of non-metallic atom?
Chlorine.
Yes, chlorine will gain one electron and it is called as non-metallic. So the terms metallic and non-metallic. So as I just said, if a metal atom is losing the electron, it is considered as metallic. And if a atom is gaining the electron to form an anion, it is known as non-metallic. Okay. So now what are the factors that will influence? As we know, that atomic radius and nuclear charge, and again here ionization potential will also come in picture. What should happen if atomic size is increasing? Metallic character should increase or decrease?
Increase.
Increase, because atomic size is increasing, ease of releasing electron is increasing, ionization potential is decreasing, so hence it will become more metallic. And it will be vice versa in case of non-metals or across a period. right? Metallic characters will decrease if you move across the period. Why? Because nuclear charge will be holding over it and you will not be able to take out the electron, because if it is not losing the electron, metallic character will not be increased, right? And non-metallic character will increase across the period, but down the group it will decrease, because as you move down the group they tend to lose electron rather than what you'll say accepting the electron. Okay, we are clear so far?
Ma'am, is there any specific reason why they have compared it to ionization potential only for metallic and non-metallic character?
Because ionization potential is the energy required to release the electron. So if you will measure the ionization potential, then you will calculate this much kilojoule is required for sodium, this much kilojoule is required for calcium. So if you have that energy changes, you can calculate for sodium we need this much energy, for calcium we need this much energy, and they are that easily losing the electron. When you have that knowledge, then you can classify that okay, it is easily removing the electrons, so it is more metallic in nature.
Ma'am, so for non-metallic character, can we compare it to electron affinity?
Yes, yes, obviously. Yes, electronegativity and electron affinity, both. And we do that.
And we can even compare both of them to nuclear charge. Right?
Nuclear charge is like universal for everything. Nuclear charge will increase down the group also, across the period also. But down the group, the number of shell that is increasing, that take over the increase in nuclear charge. But as you move across the period, the nuclear charge is increasing as the number of shell is same. So nuclear charge will dominate over there.
Okay, got it.
Okay. So now what I'll do is I will ask any of you to summarize me, whatever I have done. Who want to go? Who want to do that? Nobody. Nobody understood what we did in class? Or is it that volatile? Whatever I taught, nobody understood. Sneha, can you do that for me? Can you summarize whatever I have done or whatever you have understood in
Like
today's
the
class?
entire class?
Like now you don't need to explain all the concepts, but you need to say, see, this particular concept we studied, this we studied, whatever we studied, you
Okay,
just
so we did atomic radius and
Hmm.
we did ionization potential
Hmm.
and electron affinity and electron negativity.
Okay. Apart from that, Trisha, can you tell us anything?
Ma'am, so first we talked about like the periodic table, who discovered what and in what way, like Dauvergne, Newland, Mendeleev, and Moseley. And we
Yes.
also studied about triads, octaves, and the periodic table, and the arrangement in the order of increasing atomic weights and numbers.
Hmm.
And after that, we went to the properties.
Hmm.
1 second. Ma'am, should I like define all the
No, 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 no,
yeah, so
not
then
but hmm.
yeah, whatever Sneha said, we studied all those properties.
Okay. So what Sneha said, Sanjana? She has just control C, control V. Now you need to say what is that.
Sneha named the properties we learned. So we learned about atomic radius, then ionization potential, electron affinity, then electronegativity, electropositivity, then non-metallic character, metallic character, and nuclear charge, atomic size.
Very
And
good.
then after that, you talked about the trends down a group and across a period.
Yes. Very good. Shreyans, anything we did apart from that?
Can't really remember. Maybe the metallic character. We talked about
Met-
that also.
Yeah.
Metallic and non-metallic character across and down a period. How they vary,
Okay.
and the reason for the trends in the periodic. Oh, wait, we didn't do that.
Okay. So, you guys are sitting there. We have 1 minute. So, I just want you guys to find one odd thing. Like there are two odd things. Okay. Here, whatever we can see in screen, there are two odd things. Who can tell me what are the odd one out you need to filter? What is that odd one out? Who will tell me? There are things that are odd one out. If I will ask you, there is one thing with one person which is odd than all of us. There are actually two things which are odd. What is that? Who will tell? I guess Sanjana found out.
Ma'am, Sneha doesn't have specs.
Oh,
Sneha
Swati
nahi
doesn't have
Swati.
specs.
Oh,
Okay,
sorry,
Swati
sorry,
apart
doesn't
sorry,
from
my
have.
that,
bad.
this is the one thing. Second thing,
Sneha's wearing earphones and the other no no. Shreyansh is wearing headphones, but anyway.
no, Shreyans is the only guy. No, now Darshan sir is also there,
Yeah.
so he's the only one, and then we all are girls. Okay.
Okay. Okay. Great, folks. Thank you so much, ma'am. I think you can
Yeah,
mark the attendance.
yeah,
Folks,
yeah.
you can,
I have
yeah,
done that.
you can wait for some time.
Mhm.
Thank you so much for the session, ma'am. Yeah.
Okay, fine. So I'll be leaving the session, sir, now.
Yeah. Yeah. Yeah.
Okay, thank you so much,